Okay, so I'm gonna finish. Well, I don't know about finish. I'm gonna keep watching 1.5, and then hopefully I'll find out what a derivative is soon. We're getting there.
No, this one does. Does this sign change as well?
No.
No, okay, good.
Alright, let me think about what happened last time. Find the slope of tangent lines to just the slope, huh? To y equals the square root of x at any point. So I found to find the slope of the tangent line to y equals square root of x. I found the limit as h approaches 0, and I used the what's this called? Difference quotient. Why is it searching in there? Yeah, it's a difference quotient. So I plugged in. No, I didn't plug in anything in this step. But I substituted f of x plus h for the square root of x plus h. Substituted f of x for y equals square root of x. Plugged those into the difference quotient. Then I found the limit by multiplying the conjugate. And I didn't distribute the h so that I could cancel it out. Then you can plug in 0 from here, which would give 1 over 2 square roots of x. And that's where I'm at right now. And that should be the answer, since you're just finding the slope.
Remember, we have parentheses here, which means you're going to have to distribute. I may have parentheses here, but what I told you is you don't want to distribute where you're trying to get rid of something, right? You're trying to get rid of that h, so don't distribute that, otherwise you'll have to refactor it. So in our case, our limit, keep writing limit, is denominator again. Keep it the same. And you'll see why in just a second. But if you distributed the numerator correctly, hopefully you got this. No more roots. Do you have any roots? Then you probably did right.
Oh, the numerator, yeah.
Numerator, you're going to get x plus h, because the square root times itself gives you the radicand. That's the inside. So we have our x.
So wait, hold up. So if you, this is the tangent, the slope of the tangent line for any point, right? So if you plug in an x value, do you really get the slope for any point? That's kind of crazy. Huh.
Plus h, that's great. Our middle terms are gone. You're going to get plus root x plus h minus root x plus h. It's fun to say. And then lastly, you're going to get minus x. Show of hands how we made it that far. Great. What happens? Yeah, we have positive x, negative x. That's kind of what you need to happen, right? Geez, I told you to get it out ahead of time. What's the matter with you?
This man sneezes like crazy. When was this recorded? August.
Do you need a tissue? Yeah, I don't have one.
Well, that's when the video was uploaded. I don't know when it was recorded.
Anybody have a tissue?
It's fine.
Good. I don't think anyone else has one either.
There's no way this was actually recorded in August, right?
Thank you. I care about my students.
They start that early?
You're paying my salary. Suckers. No, I'm just kidding. Totally joking. I love you all. Anyway. Please subscribe. 20,000 views. Nothing. Want to get there? First one go on. What happens now?
He said 20,000. How many does that?
H's, sure. H's. Do you have anything
349,000.
left on the numerator?
One.
Oh, how sweet. Thank you. Look at that. So we have now a limit. H goes to 0. Can we let the h go to 0 and be okay? If we do, we get x plus 0, which is still x. Square root of x, that's okay. Plus square root of x, that's okay. So we're okay. If we let the h go to 0, what we end up getting is, notice no more limit. You have 1 over square root of x plus 0 plus square root of x. No more limit because I allowed the h to go to 0. When you're all said and done, what is that going to, what's that going to be? I'll give you the 1. 1 over what?
2 squared of x.
Not x, right? A square root of x plus a square root of x doesn't equal x. That's multiplied. But a square root of x plus square root of x gives you
2 square root of x.
What'd you just find? What is this? What's this weird thing that we just found?
What's the equation?
Oh, this is a what? That's a slope. What you just found is a slope. You found the slope of this. Well, where'd it go? You found the slope of that. That's crazy. Look at that. This thing right here is the slope. It's the slope of this curve, which looks like this thing. That's how that curve looks. It's half of a parabola on its side, right? What you've just done, you found the slope at any given point, which is constantly changing. That's pretty impressive. So here's my point. Could you find the slope at the point 4, 2? Could you find the slope at the point 16, 4, 9, 3, or anything else for that matter? Could you find the slope of that? Sure, even weird numbers. Find the slope at the point 7. You could do it. It'd be 1 over 2 times the square root of 7. You could find the slope at that. All you've got to do now is plug in the x coordinate. It will give you the slope of that curve, this curve, at that point. Do you get the idea? So if I say find the equation of the tangent line now for these points, well, you can do it very easily. So never forget that what we're actually doing, we're finding the slopes of curves. This thing is the slope of that curve, this curve, at any point x. So if I had asked you this question, so with a specific point, you'd right now be plugging in which one, the 1 or the 3?
Plug in 3, 1 over 2 square roots of 3.
You're
This
plugging
look.
in a 3. Now, of course, 3, 1 is not on this curve. The point is something like 25, 5 is on that curve. Square root of 25 is 5. So if I said find the slope of the curve at this point, which one would you plug in? Plug in 25. Do it real quick. What's square root of 25? Times 2? 1/10. Very easy. You just found the slope of this curve. It's 1/10. That's pretty flat, right? Pretty flat, but still positive. 1/10. Could you find the equation of tangent line? Absolutely. You have 1/10, x1, y1, plug it into that, and now you have yourself the equation of a tangent line. Isn't that kind of neat? Kind of neat. You don't have to do the actual specific point anymore. You can find the equation of the tangent line altogether. Well, at least the slope. Are there any questions before we move on a little bit? I want to show you a couple applications of this. Yeah.
That's good for the entire domain of
This
that function, right?
this is good for wherever the function is
Doesn't equal
defined.
0.
Okay.
Yeah.
Yeah. Now, where we're going a little bit beyond where we should right now, but where this is not going to work is where the function is not continuous, obviously, because if you have gaps or jumps, there's no slope at that point, right? It just stops. One-sidedly, you can do it. So if it was continuous to the endpoint, you could do it, but if it jumps from point to point, well, you can't find the tangent line of that. There is no tangent line for that. Also, sharp points are what's called differentiable. That's finding the slope. So something, a curve that would look like this. See that sharp point? You cannot find the tangent to that
Really?
point. Why? Well, theoretically, I mean, I could draw an infinite number of tangent lines through that point, right? Because it's not, the slope, it doesn't, I gotta back up to explain this, but what the slope is a limit going to one point, right? The slope is that limit. That means it has to exist and be the same from both directions. The slope going this way is not the same as the slope going this way. Therefore, it would fail. The limit would fail. Therefore, the finding the slope would fail. Does that make sense? So, non-continuous points, limit fails. Sharp points, limit fails because the slopes are not the same, and that's what we're looking for. I'll explain this in much more detail later, but if you haven't understand now, well, that's great. Preview. Sneak peek. Ooh, people love those. Sneak peek. Good question. Any other questions? You ready to see some applications? A few applications. Good. How to maybe use this stuff. We're going to talk about average velocity, and then we're going to talk about instantaneous velocity. We're going to see the relationship between this and this come into play again. Average velocity. If I talk about average velocity, that means average velocity. All average velocity is how far you've gone. Let me at least write it better for you. How far you've gone over how long it took you to get there. How far you've gone over how long it took you to get there.
What is it? Delta D over delta T? And delta X. I'm gonna put D because he's writing out displacement.
Well, that's exactly what this thing that I'm about to write up there says. How far you've gone can be, well, f of t sub 0 plus h minus f of t sub 0. That's how far you've gone. Let me explain this to you in English. F gives you your position, true? Right?
Mm-hmm.
This is the position when you started. This is the position after a little while. That's the plus h. Did you see that? Position when you started. Position after a little while. That's the plus h. Remember that plus h is a little while? This is your position after a little while. That's how far you've gone. If you have your position when you end minus your position when you started, that gives you your overall displacement, your overall change. If we divide that by the time it took you to change, that's the h. This is the position when you started. This is a position after a little while divided by the little while you were traveling. In other words, displacement over time. That's what that says. That right there, that gives you average velocity. Now here's the correlation between what we've just done. Think about this. What was this? What was this part? This is slope, for sure. This is actually, ignore the limit, okay? This is slope between 2 points. Do you understand? That's slope between 2 points. This is instantaneous slope at 1 point. Do you see the difference? When you get the h0. This right here is average.
Who hasn't out? It wasn't even confusing. I was supposed
Here's
to
the
pay attention.
correlation between what we've just done. Think about this. What was this? What was this part?
Oh man, where did this come from again? Let me draw it out. So you have the slope, and then you have the y value at this point, then f of x plus h. This is x, and then x plus h. So to find the slope, you're subtracting these two. Hold on. Yeah, and then you plug this in the slope formula. So this minus this, and this minus this. And there's more to it, I think. Equals m. Oh, you get rid of the x's, that's where the h comes from at the bottom. Get rid of this.
This is slope, for sure. This is actually, ignore the limit, okay? This is slope between 2 points. Do you understand? That's slope between 2 points. This is instantaneous slope at 1 point. Do you see the difference? When you get the h0. This right here is average velocity. It's just the slope between 2 points. That's instantaneous slope at 1 point. This is slope between 2 points. Do you understand? That's slope between 2 points. This is instantaneous slope at 1 point. Do you see the difference? When you get the h0. This right here is average velocity. It's just the slope between 2 points. That's how you find the average value, right? You take the slope between 2 points. That's it. That's what that is. It's the average velocity, just a slope between 2 points. That's how you find an average. So let's do one, and then I'll show you how to translate this into instantaneous velocity. And you're going to see such a connection here. Are you ready for it? So let me walk you through how to find out average velocity between a couple points. So what if I said find average velocity of, here's a position curve according to time.
Alright. We're back. Hold on, I don't want to show this on screen, but I want to see if my teacher posted the answers for the summer packet yet. No, it's not looking like it. Okay. She said she posted it in July, that's why I was wondering.
On the interval, let's do 1, 3.
Alright, let me try this. Average velocity s of t equals 1 plus 3t minus 2t squared. So we're looking for s of or make it better, f of t. What would they call this? T at 0. It's not even the I don't know. The first value of t. Which it's going to be 1. So plug 1 in. 1 plus 3, 1 minus 2, 1 squared. 1 plus 3, so 4 minus 2. F of t of 0 equals 2. Alright, and then f of t of 0 plus h. Okay. One plus 3 1. You know, this can be 1. This can be 1. Since t of 0 equals 1. F of 1 equals 2, f of 1 plus h equals 1 plus 3 times 1 plus h minus 2 times 1 plus h squared. 1 plus 3 plus 3h minus, again, 1 plus h, 1 plus h, 1 plus h plus 2h plus h squared. Jeez, man, okay. Minus 2 plus 4h, plus 2h squared. So 4 minus 2, 2, 7h plus 7h plus 2h squared, 2h squared plus 7h plus 2 equals f of 1 plus h. Okay, and then substitute it, I guess. 2h squared plus 7h plus 2 minus 2. Okay, so get rid of the 2h, well, over h. 2h squared plus 7h plus nothing over h. Instantaneous. Okay, so are we finding the limit as h approaches 0 then? For instantaneous? Because instantaneous means like occurring or done in an instant. But the problem with this is that we're finding 2 points. So it can't be instant unless the h is like super close. Unless it's basically the same time and it doesn't change. So you gotta find the limit as h approaches 0. And whenever you plug in 0, you get 0 over 0, meaning it's a whole. So you can factor and cancel, which I can see already. It's h 2h plus 7 over h this cancels out. The limit as h approaches 0 of 2h plus 7. So that means your average velocity is 7. It did say instantaneous, right? Well, it's at that point. And it'd be impossible to find out. Yeah, it's instantaneous. Okay, we're good. We're chilling, I think.
Do 1, 3. What I want to do right now is simply find average velocity. Average velocity is a slope between 2 points. Now this will give it to you. So what we need to find again is f of t sub 0 plus h and f of t sub 0. But before we do that, we might want to identify what is t sub 0, and what is h. So t sub 0 should be your starting time. T sub 0 is starting time. What's your starting time? No, it's not 0. Your starting time. Where'd you start? You started at 1. Yeah, that's where you started. H is kind of like elapsed time. Okay, it's how much time has passed between when you want to start and when you want to end on this position curve. So, can you tell me how much time has passed? How much is my H?
Nothing.
Not 3. It would be 3 if we went from 0 to 3. But we're not. We're going from 1 to 3. How much time has passed? 2. Do the subtraction. 3 minus 1 is?
Is that what it, okay. Well, I might have found something else, maybe? Copium?
H is 2.
So this is what this means, 1 to 3. I didn't know that. I'll just keep watching.
H is kind of like elapsed time, okay? It's how much time has passed between when you want to start and when you want to end on this position curve. So can you tell me when to start and when you want to end on this position curve? So can you tell me how much time has passed? How much is my H? Not 3. It would be 3 if we went from 0 to 3. But we're not. We're going from 1 to 3. How much time has passed? 2. Do the subtraction. 3 minus 1 is? H is 2. You okay with this so far? All right. Now that we have our T sub 0 equals 1, our H equals 2, watch what we can do here. What we want to find out, and you're going to see that this is just the slope formula again. Remember, we created this from the slope formula, right? That's all we did. This is only a slope formula. Average velocity then equals f of, give me T sub 0 plus H. What is T sub 0?
1,
Plus, how much is H?
2,
Minus f of, what's f of T sub 0? F of what again?
1,
All over H. How much is H? I can't afford to lose you right now. I need you to all be with me on this. Do you see where this 1 was coming from? How about this 2? How about this 1, this 2, this 1, and that 2? Huh? Yeah. So T sub 0 plus H, T sub 0 plus H, we got it. F of T sub 0 all over H. You're going to notice that when we're not allowing our H to go to 0, we have a legitimate H, because there's a legitimate distance between these points. Do you see what I'm talking about? This is the difference between average velocity and what we're going to do in a minute, instantaneous velocity. Instantaneous says, what's the time between an instant? Well, it's pretty darn close to 0. Right now, we actually have a legit time, right? We have 2 seconds, that or 2,
Okay.
whatever this is, 2.
makes sense. So this is still probably gonna be an answer, maybe? I'll move this down for now. Let's see. When does it start going off the rails? The plus H. So I'll move this down. F of 3. Alright, f of t sub 0 plus h equals 1 plus 3 times 3 minus 2 times 3 squared. 9, 10. 10 minus 18. Negative 8. I've done that wrong. Did most of it in my head. Negative 8 minus 2 over 2. Is it negative 2? Or wait. Negative 5. Let's see.
Units of time. Can you realize that when you do this, this is f of 3 minus f of 1 all over 2. You with me on that? 2. Don't change your paper, but just watch. 3 minus 1. That's still 2, right? Do you see that this is slope formula? That's all this is. F of 3 says, oh, well, that's y2 minus y1 over x2 minus x1. That's what this is. y2 minus y1 over x2 minus x1. Do you guys see the slope formula in that?
Yeah, what confused me was that these are both x values. That was weird to think about.
That's all that is. Slope formula is just the average between 2 points. If it's talking about velocity, the slope formula, this way, but we're doing this way so we can take a limit in just a minute to get instantaneous, but the slope formula just gives you the average velocity. That's it. Do you guys see the slope formula? Kind of neat, right? It looks funky, but that's just y2 minus y1 over x2 minus x1. How do you find f of 3?
Plug it in, bro.
Plug that in. Why don't you do that for me right now? Plug in f of 3, tell me what you get. Oh, you know what? Shoot. I got so confused with my f's. What should that letter really be? Okay, thank you. You know, you can stop me and tell me when I do things like that. It doesn't hurt my feelings. But I hear from your erasures that you all did the same thing, huh? All right, that should really be S, because we're talking about a position curve, we're talking about the S function. So S of 3, S of 1. What is S of 3? Plug in 3, what do you get?
What did I get?
Negative 8?
Yep.
Negative 8? Negative 8? Okay.
2 for the other one.
Negative 8 minus, what's S of 1? I don't know. You tell me. Looks like 2. How much is that? Say what? -5, that means we're going up or going down. Our displacement's changing on average from negatively, so we're somehow dropping in our position. If I asked you to find average speed, how would you find average speed?
I don't know.
Maybe you don't know. Average speed is the absolute value of average velocity. So where velocity has a vector,
Oh, okay.
right, it's vector driven, which means like you have a direction
Has to
and
go in
a
direction.
magnitude. Speed is not. Speed is just the magnitude. So for instance, if I said the average velocity is -5 feet per whatever we are, feet per second, the average speed would just be 5 feet per second. Are you with me on that? So this is our average velocity. What it says is, are we always going -5 feet per second? No, but on average we are from one point to the next. That's what this says. If I change this, would this stuff change?
Yeah.
Could you still do it? Sure.
Yup.
You understand? It's just slope. All it is just slope. Okay, I'm not going to do this one for you. It's the same thing. Now what we're going to do, let's make the jump about instantaneous velocity. instantaneous, well, we already know what average is, we just have it on the board over here. We have that, that's average velocity. The question is, if h is time, not Tim, h is not Tim, h is time.
Oh man.
My bad. If h is time, and we want to talk about instantaneous velocity, how much time elapses in an instant?
Very, very small amount.
Ah.
Zero time.
That's an interesting question, isn't it? How much time elapses in an instant? Because when you think about it, is it zero?
Very, very close.
If it was zero, that'd be awesome. We call it forever, because time would not exist. Right? Because if it was zero, you'd add 0 plus
Oh, I
0,
see.
0. Every instant would have
But it's
a value
basically
of 0
zero.
to it, right? We would never age. We would just be stuck in the same time. That might be
It
boring for you to
approaches
sit in this
0.
class for eternity. Be awesome for me. I love this class, except for you. But yeah, an instant can't possibly be 0, but it can't be anything greater than greater so we can put our finger on it. We can't say it's 0.00001 of a second or whatever you want to say. You can't say it's 0.000000001 seconds, because that would be finite, right? And you could say then, well, between one and the next, you can delineate that. But instants can be smaller than that. Is there time between 0.001 seconds and 0.00001 seconds? Yes, there's time between that. So no matter how small you make that instant, there's something smaller. Or there's something less small, quicker, even quicker. So from here to here, and then quicker than that, quicker than that. So we can't let it equal 0. An instant isn't 0. But can we let it approach 0? So the idea behind instantaneous velocity is the exact same idea behind the slope of a curve at a point. Because if we have this, which is our slope, and this gave us a slope at a specific point, this gives us average velocity, and if I let my h go to 0, it will give me instantaneous velocity. And that's the same thing. So what you know now is that the slope of a curve is instantaneous velocity. That should make sense. If you have a position curve and you find out how fast it's going up at a certain point, wouldn't that give you velocity? Average would be between 2 points. Instantaneous is at a single point. That's the same idea as the slope between 2 points and the slope at a single point. So instantaneous velocity does the same thing we did with the slope of a curve. It says here's the average. How do we make it instant? I know that this was the average velocity. This was a slope between 2 points. What do I want to have happen to the h if I'm talking about an instant? Where's it
Approaches
going? And what's the only thing that will allow me to let h approach 0?
Limit.
So I'm going to take limit.
That's pretty cool. Hold on.
That is instantaneous velocity. We just have to understand that, see the connection between it. It's kind of cool, right? It's the same thing. The slope of a curve at a point is instantaneous velocity. The slope is average velocity if you're talking about a position curve. You want to see an example?
Yes.
Thought you would. I hope so, at least. Because I have some ready for you.
S of t equals 500 minus 16t squared. We're looking for the instantaneous velocity. T equals 5. Or wait, 5 seconds. Wait, I'm confused. Wouldn't you just plug in 5? Or no, okay, wait. S of t, well, that's part of what you'd have to do, I think.
Your position curve is S of t equals 500 minus 16t squared. That approximates some gravity curve probably because of the negative 16t squared. That's about how you approximate that. Dropping from maybe a 500-foot cliff or something. I don't know. Find the instantaneous velocity after 5 seconds. So how fast is this thing falling at exactly 5 seconds? I don't want average.
Whoops. Times 25, 400. So S of t is 100. S of t plus h, 5 plus h, equals 500 minus 16, 5 plus h squared, 5 plus h, 25 plus 10h, plus h squared, actually it's gonna multiply 16. 16 times 20, I already did that, it's 400. Negative 400 minus 160h minus h squared, 100 minus 160h minus h squared, negative h squared minus 160h plus 100. And there's a 500 there too, I guess. So could simplify that more. 600 negative h squared minus 160h plus 600. Plug this into the difference quotient. We got 100, no, h squared minus 160h plus 600 minus 100 over h squared minus 160h plus 500 over h. Find the limit as h approaches 0. You plug in the 0, there's a 500 on top still. That's the problem. So it's gonna be something infinity. I'll just watch the video from this point.
I don't want from 0 to 5. I don't care about that. What if I know know this is going to, here's maybe a relationship. What if I know this is going to impact something at 5 seconds? What I'm going to want to know if I want to protect a windshield or something, I don't know, protect some sort of glass, I want to know how to protect, I don't care about that. What if I know this is going to, here's maybe a relationship or something, I don't know. Find the instantaneous velocity after 5 seconds. So how fast is this thing falling at exactly 5 seconds? I don't want average. I don't want from 0 to 5. I don't care about that. What if I know this is going to, here's maybe a relationship. What if I know this is going to impact something at 5 seconds? What I'm going to want to know if I want to protect a windshield or something, I don't know, protect some sort of glass, I want to know how fast that's going so I can say, is that glass going to hold up or not? Right? Average isn't going to give it to me. Instantaneous would. So how fast is it going at the moment of impact? When's that how fast is that going? Then you could derive how much force that is and how much you're going to have to hold up under a certain load or whatever that case may be from physics. But here, right here, this is pretty important for us to be able to find the instant velocity of an object at any given time that I say. The given time I say is 5. Now you can see a connection between what we just did and what we're going to do now, because it is the same exact idea. What we want to know is instantaneous velocity. And what I've given you is that's the limit as h approaches 0, s in this case, t sub 0 plus h minus s of t sub 0 all over h. What is your t sub 0? What's the time at which you want to find the velocity? 5. So you know that t sub 0 is 5 seconds. Okay? There is no starting and ending time, folks. You're starting at 5 and you're stopping at 5. Well, stopping a little teeny bit past 5, but it's so close you can't tell the difference. So there is no 2 times. There's no average. There is only 1. There can be only 1 pi lambda. So it's just like that. Anyway, so t sub 0 is 5. Can you do what we did before? Can you find s of 5, s of 5 plus h? Do you see where the s of 5 and s of 5 plus h are coming from? That's what we want up here. We actually just did those examples just a little while ago. Now, another question is this. Could I have asked it a different way? Could I have asked it, hey, find me the instantaneous velocity at any time? I hope you're with me on this. If I asked it, find the instantaneous velocity at any time, would you have a 5 here?
No.
Would you have a 5 there? You would just leave it as t, and then you come up with a formula, and you could plug in any time that you want. How many people feel okay with that? I hope you're with me on this. If I asked it, find the instantaneous velocity at any time, would you have a 5 here?
No.
Would you have a 5 there? You would just leave it as t, and then you come up with a formula, and you could plug in any time that you want. How many people feel okay with that idea? So that was the 2 connections that we had to make. So let's go ahead, let's plug this in. What is s of 5 plus h? Can you tell me? S of 5 plus h. That says go to the s position curve and plug in 5 plus h. Don't all talk at once.
500.
500, great. Okay, 500. And Sarah, you said minus. Minus what?
16. 5 plus h.
16.
5 plus h.
5 plus h. If 5 plus h is non-separable, it has to be there. 5 plus h. And then what? Well, let's look at it. Are you okay getting from here to here? You see where it's coming from? This is just the position curve at 5 plus h. It's a composition. Take this, put it there. How much is s of 5? S of 5 says take 5, plug it into your function. What do you get?
500 minus 16.
500 minus
16 times 5 squared.
Sure, so 500 minus 16 times 25. I have no idea what that is. Help me out with that. No, calculators, go quick. How much?
I think it's
100? I'll believe you.
Is that what I got? Yeah.
Okay, I kind of had some drop off in participation. Ladies and gentlemen, do you know how to find the 100? Is it 100? Do you know how to find the 100? Do you know how to find the 500 minus 16, 5 plus h squared? You see where that's coming from? You sure? We're taking this, we're substituting it into our function. That's 5 plus h, that's our t sub 0 plus h. That's giving us this expression. If we're to substitute these two things, well, then we've got h. We have 500 minus 16, 5 plus h squared minus 100.
That's 550.
Better? Okay. We'll continue this next time. We'll find out exactly how much instantaneous velocity is. Put that out. Well, good afternoon. How are you guys doing?
Oh, yeah.